Hello. The next functional group is aldehydes. Aldehydes. Now these aldehydes have general formula CN H2N plus 1 and CHO. This is represented generally in this manner. Here the value of N starts from 0. From 0, 0, 1, 2, 3, 4, so on. If we put 0 value for this functional group, then the first member comes, which can be represented as HCHO. And this is represented as HC double bond O and then H. Then H. Now, on the basis of the nomenclature, depending upon the number of carbon atoms, there is only one carbon atom present in this compound. Due to the one carbon atom we know that the single carbon atom containing compound is named as methane. Methane. Say. Methane. The E of methane is removed due to this functional group. Due to this functional group. E is replaced by Al. Methanol. This will become methanol. And if I put N value 1, this will become CH3. Now, this compound will contain 2 carbon atoms. Depending upon 2 carbon atoms, we will write down ethane. And instead of E, we will add Al, ethanol. In this manner, from this general formula, we can also develop a homologous series for the aldehydes. These are aldehydes, and this is the method to name the functional group containing C double bond OH. And this is also called as a formyl functional group. And this is the method to name. All these are, if we add Al and if we see at the end of the name of organic compound Al, definitely this will indicate that aldehydic functional group is present. That compound is aldehyde. Now next is ketones. Ketones. Generally ketones are represented just like this. This is the method to represent ketone. As both of these sides are not occupied by any other atom, automatically this is considered that both of these positions will be definitely occupied by carbon atom. No other atom comes on both sides except carbon. If both sides is occupied by the carbon atom, then this functional group will be called as a ketone. And this is the general formula of ketone, where the value of N and value of M, because both sides alkyl group will come, we have to use the general formula for both sides, but we have used 2 different letters, N or M. Both sides alkyl group might be same, might be different. For example, if I write here CH3, both of these alkyl group will become same. So the name of this carbon atom will be, as 3 carbon atoms are present, according to the alkane parent hydrocarbon, propane will be written. Propane. This will be written. But due to this ketonic functional group, we will remove this E of propane and will add ONE. And the name will become propanone. Propanone. This will become propanone. Both the alkyl groups are same. But if one is methyl and second is ethyl, now what will be the name? Now the name of this compound will be, due to the 4 carbon atom present, name will be butanone. What will be the name? Name will be butanone. Now, still, there is no need to mention the position of the functional group because the total number of carbon atoms present is smaller and we can't mention its position. But if we have the formula just like this, this is CH3, CH2, CH2 and then C double bond O and CH3. Now, what will be the answer? Here, the need to mention the position of functional group is a necessity. As this is the functional group, we will start from this carbon atom as a number 1. This is number 1, this is number 2, 3, 4, 5. From this side numbering will be wrong because the functional group is present on the closer side from that side. Now, the name of this compound will be written as 2, and total number of carbon atoms are 5. That's why name will be 2-pentanone. 2-pentanone. This will be the name of this carbon atom. But if we change the position of the functional group from here to here, if we change the position of functional group from here to here, what will be the name now? Now the name will become 3-pentanone. Due to the change of the number of carbon atoms on which carbonyl carbon is present, the name is also changed. We know that if IUPAC name change and the same formula, same number of atoms remains, both of these are called as isomer of each other. But that is something else. We will discuss later on. This is the functional group ketones. Next functional group is arenes. Some organic compound contain benzene as an essential part. Now, benzene is represented just like this. This is called as an arene functional group. If one hydrogen is removed from it, this will change into just like this. And this will be called as a phenyl group. And if substituted phenyl group, we are considering that definitely that will be called as aryl group. Aryl group. In this manner, we can name. If we put here CH3, only one substitution, this will be called as a methyl benzene. All these are called as aromatic hydrocarbon, and the compound containing benzene are called arenes. This is the main functional group which give a special type of properties to the organic molecule. Sometimes only single benzene rings are there, but sometimes more than one benzene rings are fused with one another, giving different types of the organic compound, but all those are called as aromatic hydrocarbon, and the functional group is called as arenes. Next is the functional group carboxylic acid. The general formula for the carboxylic acid is CnH2n plus 1 and then COOH. We have already discussed all this. Now again, the value of n starts in case of carboxylic acid from 0, 1, 2 and 3 and so on. If we put 0, then we will get the first member of the carboxylic acid series, that is HCOOH. Now, what is the method to name these carboxylic acids? These are also represented as just like this. Both of these are same. Now, depending upon the number of carbon atoms, as only one carbon atom is present in this, first of all, depending upon the alkane, we will write down the name as methane. Methane. But due to this functional group present, we will remove this E by OIC acid. OIC acid. So if we combine all these words, the name of this organic compound will becomes methanoic acid. Methanoic acid. If I put N is equal to 1, then the formula will become just like this. As this will contain 2 carbon atoms, this will be called as a ethanoic acid. Ethanoic acid. And if we use this organic compound which contain 2 carboxyl group, then what will be the name? 3 carbon atoms are there. This will be called as what? 1,3 propane dioic acid. 1,3 propane dioic acid. Propane dioic acid. Propane dioic acid. It means that 2 carboxyl group are present in one molecule. So if the functional group or same type of group is present for more than one time, definitely the prefixes di, tri, tetra, penta we can use. In this manner we name these carboxylic acid and with monocarboxyl group or with di or tricarboxyl group. Now the next functional group is esters. Esters. What is the functional group? Functional group for this ester is represented as C, double bond O and O. And briefly, this is represented as C, O, O and then line. It means that as we have in case of canteen left to the 2 position vacant, now vacant position will be sure that this will be occupied by only carbon atom, not by any other atom. For example, if we write down here H, this will become carboxylic acid group. So no need to write here H. Now on this side hydrogen can be, but on this side hydrogen cannot be. That's why this will be definitely occupied by the simplest alkyl group methyl, and here might be hydrogen comes. Now how we name this organic molecule? First of all, we mention this alkyl group as a branch, and then we find out the total number of carbon atom on this side, and we mention what will be the name. This will be mentioned first, methyl. Then how many carbon atom present on this side? 1. That's why name methane will be written. But removing E, for this functional group we will write down OADE at the end. So this will become the name of this organic molecule, methyl methanoate. Methyl methanoate. If I use here CH3, then this will become methyl ethanoate. Methyl ethanoate. If I write down here, if we increase here another carbon atom, then the name of this hydrocarbon will be ethyl ethanoate. Ethyl ethanoate. Now in this manner, esters are named and we find out where the ester linkage is present. This is the ester linkage which we have already discussed in O-level class in polarization. I have explained functional group and relative all information. Please do like, share and comment, subscribe my YouTube channel for the next upcoming lectures. Thank you.